Hi, everybody. I welcome each one of you on to this webinar. The webinar theme is transformation doesn't happen overnight. Who doesn't need transformation? Here is one solution that helps you improve quality instantly by automating the tool, the bare offset correction. So the webinar theme is auto tool bare offset correction and SPC. SPC as in statistical process control solutions. Nothing but improving quality at source and minimizing operator intervention. You'll have two speakers speaking today. One is Mr. Umesh Miglani, and the other is from Mr. Ramesh J. Our Mr. Ramesh J. He's thank you, sir. He's supposed to be the Kevin Ashton of Micromatic. If everybody is wondering who's Kevin Ashton, he is the father of IoT. He was the first one to actually come out of it. For our Micromatic, Mr. Ramesh is a sales and business development professional with 25 years of progressive accomplishments in enterprise sales and consultative selling, and skilled at reading through complex customer solutions, situations, business development, and technology sales. He currently leads the sales efforts for Micromatic IoT solutions. And the second speaker is actually Mr. Umesh Miglani. He is our DGM quality of Sona Comstar, who will delve deep into Sona Comstar's ATWOC adoption journey and benefits. ATWOC, when I say it is auto tool bare offset correction.
So, good afternoon all. I am Umesh Miglani, an engineer with Sona Comstar. With 23 years of experience in manufacturing processes, I have honed my skills in implementing innovative solutions for Industry 4.0, like auto tool bare offset, traceability, machine health monitoring, AI vision-based inspection. Today, I am excited to share insight from our journey and impactful results what we have achieved so far. I look forward to engaging with you on the topic of auto tool bare offset into our CNC machines. So the project will lead the way in Industry 4.0 at Sona Comstar with using unique statistical tool and reducing the human skill dependency by transferring into automation. So this is the content of my presentation, starting from company brief, where we implemented this auto tool bare offset manufacturing process and our hard turning operations, our PDC approach, which we applied onto this project, and finally results and the benefits which we got. The product range at Sona BLW are differential bevel gear and pinion, differential assemblies for EV, helical gears, engineering products for transmission and driveline for all three segments: passenger vehicle, commercial vehicle, and off-highway vehicles. So this manufacturing process of hard turning consists of various steps. The project is focused on basically hard turning operation. In this process is carried out on CNC turning machine by using special jigs for the clamping of part. Boring bar with insert are used for hard turning, and the specification within specification of 20 to 80 micron. These are the specific jigs which we use for hard turning operations. So objective we set as to improve process stability at hard turning operation, incorporating first of all digital inspection and auto tool bare offset to eliminate manual intervention in the process. And the target which we set for auto inspection to be initiated with facility of auto process adjustment into the CNC machines. And we propose the benefits: elimination of manual inspection and the adjustment, manpower reduction, one man can operate two machines, and auto recording of inspection data, and the continuous run chart onto the screen for our basically observation or action accordingly. So these are the approach which we applied onto this project: plan, do, check, and act. So this is the planning of the project. We select the part for taking trials, capturing the natural tool wear through statistical, generating tool wear offset calculator. Basically, this is the calculator where we started the project, and trial with this calculator, establishing the auto adjustment mechanism on CNC machine, and monitoring the auto adjustment and taking improvement action further. So this is the part selection criteria carried out by prioritizing the critical parameters. Manufacturing hard turning operation based on monthly sales volume and rejection trend. We selected one part out of 250 plus parts which is having higher rejection in our rejection criteria. So this is the selected part. We selected one machine also for taking trial M71. The tolerance for the part is almost 27 micron. How the adjustment process works? Basically, this is tool wear offset is provided in CNC machine for the compensation of the insert wear. The tool wear offset are provided for maintaining the parts at the mean value, and the operator is taking the tool offset based on his skill or based on his knowledge, and no statistical tools are applied to know the adjustment amount. So these are the present adjustment process, manual intervention. Machine operator is operating the machines and carried out 100% inspection of the parameters. The process requires the machine operator to be present on the machine at all the time to inspect the part, to provide tool wear offset into the machine as per their experience or need, to record the observed value into his docket PDI, periodical inspection reports. As per our normal process, machine operator does into 18 offset per machine, per spindle or per shift. He does the offset. So we started with first experiment in order to understand the process behavior. We conducted a trial without taking any offset onto the machine till sufficient number of rejection were produced. So this is the trend of the natural wear of the tool wear. You can see almost 140 parts are within specification, and after that natural tool wear and parts coming into the lower side of the specification. This trial is conducted without any given to the offset into the CNC machine. Then we understand the data by plotting best fit line and observe the equation for where to adjust. Then we simulated the data with respect to the if operator does the offset every part, so how it looks like. So you can see dotted lines are simulated line and the colored one lines are natural tool wear offset. Tool wear. So the difference between CP and CPK, if the tool is naturally wear, then CPK comes around 0.3755. If operator does the frequent offset as per inspection data or need, the CPK is coming 2.47. So based on this simulation and actual tool wear, we developed a in-house calculator based on linear regression to calculate the offset value after every 20th of the part. So this is the mathematical model which we created for first experimental and started trial on the machines. So we provided one laptop on the machine near to the operator. He sets the part as per the part specification and inspect the part, monitor the 20 readings into the Excel sheet and do the offset correction as per the requirement comes into this calculator. So we conducted complete trial with this calculator and we observed the CPK is coming more than 2 on almost 720 numbers which we produced for the specific parts with this linear regression mathematically model for calculator which we prepared. So we got some concern during these trials. Offset is calculated at a set of fixed interval, say after every 20 parts. So it does not consider tool wear pattern. It is coming fast or slow, and we can't take any action for first 20 parts. Then these 20 parts can be out of specification or within the specification. And assumption is wrong if the actual data is not normally distributed. So these are the concern. Then we thought about some alternate solution for compensation onto the CNC machine. Then team suggested for exponential weightage moving average, EWMA. So that can quickly detect a small shift into the process towards mean that is robust to non-normality of the data. And it can forecast where the process means, like when to adjust the process and how much process adjustment is required. So this is the application of EWMA. So we see the advantage of the EWMA method. One is we can predefine the L value into the offset calculator based on the requirement of process capability. The resultant data of the output of EWMA chart is normally distributed. Immediate response can be provided through EWMA. it can calculate the control limits within the first 3-part sample manufactured on the CNC machine. As an effective process control tool, it regularly learns the process behavior and act accordingly. So with these advantages of EWMA, we thought it is much better option for auto adjustment process. So we prepared a automation for adjustment plan onto the one CNC set. So these are the activity plans starting from conceptualization, selection of auto adjustment device, implementation onto this hard turning operation, conducting trials, establishing the auto adjustment device. So prior to this, we required one partner for this auto tool wear offset implementation. So we selected ACE Micromatic for this project based on 2 criteria. Out of 6 projects, 3 successfully implemented in our plant. One is production monitoring through TPM track. We can monitor 16 losses, and this is for productivity improvement. Next one is condition-based monitoring for machine health monitoring. And third, for energy monitoring, process energy monitoring. So that's why we selected ACE for this auto tool wear offset implementation. Another best part is from ACE is 24/7 service and support and technical capability. And we have near to our plant, these services available with us. So this is the conceptual of auto compensation of hard turning machine. We required basically two points here. One is measurement device, another is smart toolkit for auto tool wear offset corrector. So these are the concept view from before and after. You can see top view is the before for existing process where we turn the job. Operator does the manual inspection onto the gauges, record the inspected value into the docket periodical inspection report, and does the correction into the machine based on the result value. But after implementation of measurement device or auto tool wear offset kit, job turns digital measurement onto the measurement device, auto analysis through auto tool wear offset kit, and EWMA concept which we implemented on this tool, and auto correction to the tool set. So after implementation of on this one CNC machines, our CP and CPK is improved from CP earlier was 1.93. Now CP is coming 2.47. CPK improvement is 1.69 to 1.93. The reduction from 556 ppm to 67 ppm. Reduction in rework is also from 1512 ppm to 312 ppm. There is another benefit which we got from in terms of quality, stable process, reduction in rejection and rework. Our productivity also improved because of this manual offset correction and less dependency of skilled manpower. The best part is from this system we got at the end of every shift, we received one report of SPC, process capability report, and another report comes from system for the corrected value at which interval tool set give the offset to the machine. Based on the learning and the results which we got from one model machines, we plan to diffuse into our another plants and our sub suppliers. We started this journey in 2020 with one machine M71, and then we planned for 12 machine in February 2021 on 12 hard turning machines lines converted into Gurgaon with auto tool wear offset, and July 21 we converted 53 machines in our all 3 plants, and April 22 85 machines in totality we have implemented with auto tool wear offset, including our 34 machines in Gurgaon, 20 in Pune, Manesar 12, and 19 machines at our sub-supplier they have implemented. Overall benefits and the results which we got from this system, 90% reduction in our overall machining rejection. This is the major achievement which we got from this auto tool wear offset. In terms of quality, stable process, reduction in rework and the rejection, productivity improvement, number of parts per hour, and in terms of people morale, less dependency of operator skill and reduced activity of the operator, which is manual inspection. These are the overall results which we got from this system. Thank you.